Can you guys hear me?
Yes. Hi.
Okay. Just want to make sure I didn't lose.
Okay. Hello, everyone. Thank you for joining our webinar on event-driven architecture. We are excited to have you with us. My name is Fatih, and I will be your host for today's session. We will discuss some topics like event-driven architecture, why event-driven architecture is relevant for SAP and retail. We will also cover some use case and benefits. Joining me today, Giuseppe and Fatih is here. Giuseppe, can you introduce yourself?
Sure. My name is Giuseppe Bruni. Hi, everyone. I am in charge of the partnership between Solus, the company behind SAP Advanced Web Mesh, and SAP. Nice to meet you all.
Okay. Then Fatih.
Hi, I'm Fatih Pense. I work in MDP Group for 10 years, integration, working on integration and consulting. So nice to be here.
Fine. Okay, then let's start, Giuseppe.
Awesome. Guys, thank you for making the time. Really appreciate that. What are we going to do today is we're going to give you a bit of a journey around what is event-driven architecture, why bother. We're going to see how it works, and we're going to see some use cases. We're going to spend particularly a lot of time on the use cases because use cases often give a better view of how the technology works. And then we're going to show towards the end how it fits in the broader SAP architecture and SAP integration space. Let me start by discussing why real-time and what is real-time. And I'm going to take retail as a customer journey example, but this could apply to any other industry. Retail just happens to speak to most of us because we all deal with it on a day-to-day basis. So what is a journey in non-real-time? What is really happening today? Companies think they are real-time, but they're really not. So if you normally go to a supermarket, what happens sometimes is you've gone out to buy a certain product, and that product is not available. It happens very often to a lot of us. And that's a typical non-real time. Often the last product is bought by a customer, and then the supermarket doesn't know until the end of the day that the product is gone. And so we just do the trip for nothing. In a real-time world, as soon as the product is bought, the aisle automatically informs the supermarket central system. An event is created, and then it's dispatched to the aisle replenishment people who can go and replenish it within a few minutes so that there's no loss of sales. Just to give you how big this is for retailers, retailers in average lose 8% of their revenue yearly out of stock. So the shelf not being replenished on time. A couple examples more. You might be an IKEA customer. IKEA had the issue that until some time ago, if you would buy an furniture online, say you buy a Billy, they would tell you, that's great, thank you for your purchase, go and pick up your furniture at this location. You would drive in traffic, only to arrive there 1 hour and a half later to be told, thank you for buying it, but actually it's not available at the store anymore. The online view of the inventory was not the same as what was happening at the store. And so, frustrated customers. Right now, IKEA was able to solve that issue. And if whatever you see online is exactly the real-time view of what happens in the store. So as soon as a product is sold at the store, instantaneously every inventory is updated as well as the inventory availability online. Instead of relying on a typical batch type of work, which gives you a huge delay. And the final example, loyalty points. What happens to a lot of customers is they go to the supermarket or to any retailer, they get loyalty points, but then it takes them days before they're about to use it. And that was certainly the case at Lidl, one of the biggest retail supply chains in the world, where customers were doing the shopping. They knew they would have reached the loyalty points thanks to the last shopping. They wanted to buy the products, and they were told, well, sorry, you need to come back in a few days. Today, Lidl has a very famous app for loyalty, and the customers are able to get the points instantaneously. The moment in which the cashier registers the sales, the points are in the bag. They can use it right away. So why is this happening? Why this difference between the non-real time and the real-time world? That's happening because in most cases, organizations rely on one out of these two types of connectivity. Type 1 is batch delivery. Batch delivery means overnight or over a few hours, you transform and pass a lot of data from A to B. And so you have to wait for that batch to get the latest level of data. Or option number 2, they rely on periodic polling. So for a system to know whether something has happened on the other side, for a system to know if there's been an event happening, it needs to keep polling, it needs to keep asking the other system, has anything happened on the other side? Has anything happened on the other side? And that is, of course, very wasteful, and it creates one out of two issues. Either you keep asking very often, very frequently, every second, and that generates a lot of messages back and forth, which is very wasteful, or you ask every interval, say 10 minutes, but that means you're going to have a 10 minutes delay. So obviously, this can be solved if you have immediate alerts. So if you can be informed as things happen. So, comparing the previous polling example to a kid being in the back of the car and who keeps asking, have we arrived? Have we arrived? Have we arrived? Every few seconds, you can just tell the kids, here's your navigator, you know exactly where we are in each point in time. So how do we do this real time? And by the way, why do we need it? Gartner says the world is event driven. Things are happening in real time in the world. We cannot just wait for a system to inform us. The things have happened. And the longer I wait for doing something about that event that has happened, the less competitive I am. The level playing field is having a product in the aisle. The competitive field is, can I be real time? Can I work as a real time company? So this is how companies are operating today. They have a spaghetti architecture where every time they introduced an application, whether it was on the cloud or on premise, to their architecture, they had to draw a number of lines, a number of interfaces between their application and all their other applications they need to integrate to. And pretty soon it becomes a fairly unmanageable situation. If you have 2 applications, you need 1 interface. If you have 3 applications, you need 9 interfaces. If you have 25 applications, you need 325. So it grows exponentially, and it becomes exponentially more difficult to manage. Advanced event architecture and event-driven architecture changes that by creating a layer which is called the advanced event mesh. And the only connectivity that applications need to have is one connectivity to the mesh. From that point onwards, any events that they generate is forwarded to all the other applications in the ecosystem. So you go from having hundreds of connectivities that are needed, hundreds of point-to-point interfaces, to only one interface, to the mesh, and then the mesh takes care. So this obviously has a number of advantages. Number one, you have a response which is real-time. It's instantaneous. As soon as an event is generated to the architecture, all the applications in the architecture get to know about it within milliseconds. You don't need to have a delay so that the data goes from A to B, from B to C, etc., before it reaches the destination. You have fan-out calling, so you don't need to duplicate data into pipelines. You don't have duplications of data. The data is generated in one source, is instantaneously available to all other destinations. You don't need to copy-paste this data over and over in your architecture. You have dynamic routing, so you know who the mesh that you've seen before decides who has registered to the message, who should receive that message if they're interested. I'm going to explain that in a minute. And very importantly, you have decoupled connectivity, and this is very key. So in other words, what this says is, I don't need to know where this information is coming from. I don't need to connect to an application, right? I just need to know that the information is out there in the architecture and that I can make use of it. So if I'm the generating application, because I don't need to know who's receiving that information, I don't need to change my interface accordingly. I just publish it to the mesh, and whoever wants it receives it. And finally, discovery event. So if I'm a developer, I can have, similar to APIs, a catalog of all the available events that I can tap into so that I can use them in my application. So how does it work in practice? You can see here the architecture in BTP. You start what you call the Advanced Event Mesh console. In there, you monitor the mesh. You can create a mesh you can monitor. you first install a number of what we call brokers. The brokers are what generate the mesh. Each application only has to connect to one broker. And then the brokers can find each other, they create with each other a mesh. And then any application is sent to the broker is then forwarded to the other elements of the mesh. In the console, you have anything from a mesh manager, which can help you to monitor and manage the mesh. You have an event designer, so you can see all the events that are going through the mesh. You can design them and manage them, and you can also have the event catalog. How do these events look like? They're very similar to what you do when you use Twitter or Instagram. If you use Twitter or Instagram, you often publish something to the world. You say, this is my picture. You give it a hashtag, say hashtag metaverse or hashtag vegan. And then anybody who has tuned into that hashtag will receive the picture, right? I don't need to know who will receive it. I don't need to send it to friend A and friend B and friend C. I just send it to the world, and the filter, it does the work for you. Similarly, event-driven architecture works with events that are structured in topics. And these topics typically have a form of a noun, a verb, and an adjective. The noun is the object that is generating the event. The verb is what has happened to that object. And the adjective gives you additional information. For example, an event could be payment, that's a noun, initiated, so that's what happens to the payment. And then you have some additional information like, it happened in a specific corporation in the US. If I'm receiving event, if I'm one of the 1,000 applications that will receive the event, I can only tune into the events that I'm either allowed to tune in or interested into. Now, there's obviously the security element where I might not be getting access to some of the events. But if I'm interested in specific events, say, for example, I'm only interested in the payments that have been initiated in Singapore. I can use a hashtag and star type of structure so that I can filter out only the information that I am subscribing to. In this case, for example, I'm saying to the system, to the mesh, only let me know the payments that are initiated in Singapore and not any other payments. So that's pretty clear. All right. So this is just another example. These are orders that have been shipped for a specific unit. This is the message. I can tune into it, but I can say, let me know if any order is canceled for that unit in any country, right? Let me show you, and I'm not sure the audio will be audible, but I'll play a quick video of a company that is implemented, and then we're going to go through a number of examples.
We can hear, Giuseppe.
Okay, awesome.
We had situations where goods were being delayed at customs, resulting in high detention and demurrage costs. Part of the problem was that we lacked real-time visibility into the movement of ships and cargo. To address this and other ocean shipping challenges, we created the Virtual Ocean Control Tower, using Solus Event Mesh for real-time, event-driven data movement between all the components and technologies in the system. The Virtual Ocean Control Tower connects 25 shipping lines and uses satellite data to track more than 2,000 vessels and 400 ports, as well as hundreds of raw and pack material suppliers. Over 20 different types of digital events are generated and published to Solus. Events like vessel position, container logistics, port congestion alerts, and CO2 emission alerts. These events are consumed by a variety of subscribers, including our Virtual Ocean Control Tower dashboard and an interactive Google map, giving users an overall view of goods in transit and helping us optimize vessel speed, navigation, arrival, and departure times for maximum efficiency, safety, and to help reduce our environmental impact. This digital innovation is helping us significantly reduce our detention and demurrage costs.
So let's look at Unilever. And I hope you heard the audio if it was high enough, but Unilever has a challenge. Unilever wants to have in real time the view of 12,000 containers and 1,500 ships. Because the challenge they have is very often what happens is a container arrives at the harbor and it's sitting idle at the dock. Nobody's picking up the container. And the costs for keeping that container at the docks are very high. It costs them almost as much, if not more, to keep that container at the dock for 1 day than it takes them to ship that container from the other side of the world. So it's very high cost. They want to know where the container is so that before the container arrives, they can send a truck to pick it up. So the truck is there waiting for the container as soon as it arrives. The challenge with knowing where the containers are is that they need to integrate with shipping authorities, freight forwarders, port authorities in 160 countries. So if they want to have that overview, in the traditional sense of connecting point to point, they need to build hundreds of interfaces. And every time they consider this project, they decide to shelf it because it would take them 2 years and would be way too expensive. They decide to go and use event-driven architecture. Within 9 weeks, they're live. Since then, they're saving 10 million year on year just on demurrage costs, so the cost of leaving the container sitting out of the dock. Very importantly, they're improving the capacity of the container by 10%, which saves them many more millions than just the demurrage cost. And in matter of hours, they were able to resolve the Suez Canal crisis. So when the Evergreen was stuck in the harbor, a lot of ships could not move. They were able to decide which ship would go under the Horn of Africa to be delivered as soon as possible, and which ships could actually stay in the Suez Canal, basing their decision on cost as well as on CO2 in real time. So real-time what-if decisions. Very often you see this beautiful dashboard from SAP Analytics Cloud, which are fantastic, but the problem is that the data behind it is often not in real time. This enables Unilever to make it instantaneous. Let's look at a couple of other examples. I purposely chose examples from different industries because I know you guys are coming from different backgrounds. I have a bit more on the retail because it speaks to all of us, but I do have from other industries as well. This is the case of Edeka. Edeka had the issue that a lot of the fruit and vegetables would expire at the end of the day, like any retailer. But the problem is they wanted to update the price to give a discount so that the people could buy the veggies before they would expire. Happens in a lot of supermarkets, but a lot of supermarkets, the way they do it is just program it. They don't really look at the way the fruit is. They just, program it a few days in advance. And so very often they actually sell fruit that is perfectly fine. Or in other cases, what happens is that, you have a heat wave, the fruit is about to go away faster than you planned it. And so you discount fruit that has already gone bad. So their challenge was they would update the price in S4 centrally, and it would take a whole day for the price to be updated at the store because it would happen through batch. They would decide to go to EDA. Since then, within seconds, the price is updated on S4. It is also updated on the 6,000 stores. They're also able to change prices multiple times during the day. If there is a specific need in a region, so there's been a heat wave, so I need to discount faster, or there's a rain and I need to increase the price of umbrellas, they can do that. So lots of fresher products, waste reduction, and obviously much improved customer experience. An example from fashion is that of Richemont, who wanted to have a more personalized advice as the customers enters the store. And that is typically possible if the employee knows the customer. But very often what happens is you have customers that are very loyal customers in other regions that you don't know. So what they're able to do now in real time is, as you enter the store, in some of the countries where this is allowed, they can recognize your phone, they know who you are, and the op-ed of the seller showcases that you have been, for example, a couple of weeks back in Shanghai. Now you're in the store in Dubai, and you are, they know that you have selected a watch a week ago, but you didn't buy it, and you can say to the customer, we know you like the Cartier. You've seen this model last week. How about I show you another model? So very personalized, instantaneous experience.
Interesting.
This is a case in Germany. One of the very famous manufacturing company in Germany who created a digital twin type of company, a production plant. There are a couple of challenges there. The production plant is working fantastically. One of the issues is they needed to be as quick as possible to either repair machinery as soon as it breaks, or to actually repair it before it breaks. So, what this lady was sent to was a machinery before it was even broken. They can send events to the person to say, make sure you go there by 3 p.m. Otherwise, the machine is about to break. Another thing they were able to do was to actually enable the inventory in motion to be produced in a way that each machinery runs at full capacity. So what happened before, they were in real time, some of the machinery will run out of semi-finished goods, and so they would actually have to stop producing until the machinery before them would produce the semi-finished good, or until they would get the raw material. In this way, for each machinery, in front of each machinery, they do what is called demand-driven material resource planning. So they ensure that there's enough inventory for the machinery to run, but not too much inventory so that the company loses money. And so there's a continuous flow of production. Thanks to this manufacturing company in Germany, which is a very famous brand, enabled the production to increase efficiency by 25%, which is unheard of in manufacturing, just by having a digital twin and a real-time view of the production.
Mhm.
A case that would speak to a lot of our Turkish and German friends is that of Mercedes. They have an app which allows you to lock and unlock the door of the car. It does many more things. You can start the car, you can start the heating, you can monitor the level of fuel, etc., etc. The challenge they had with opening and closing the doors is they used to have an API-based architecture with the type of model I showed before, where you only know something if you ask if it happened. And that was not really scalable with the 10 million users that they have. So it would take up to 8 seconds from the moment in which you click the button to the moment in which the doors of the car would open. So you can imagine you're in front of the car, it's cold, and you're waiting 8 seconds for your car to open. They went in real time, and they're now able to open the door of the car with the same speed that they would open if they would use the keychain of the car, right? So same speed. You can do them in parallel. It takes milliseconds either way. So instantaneous experience, very happy customers. Mercedes is not the only one. Renault, Peugeot, etc. A number of manufacturers are using that as well.
This is very interesting example, I think, to understanding the event mesh within the automotive industry then. Good.
Thank you, Fatih. Thanks.
Yep.
Appreciate it. I'll go, if you guys are okay with that, I'll go through a couple more examples, and then, we'll look at how this fits with the broader, ecosystem of SAP. And I'll bring you an example of, we'll see this as a retailer, but it's actually Heineken that started this before. Heineken had the issue that they would get bursts of orders. They would get a lot of orders that their architecture was not able to manage fast enough.
Mhm.
So what happens every morning around Europe, in every restaurant, there's going to be a Heineken reseller that comes to you and say, how many beers do you need today? This happens between 9 and 11 in the morning, where the restaurants are open for suppliers, but not for customers. So Heineken would get in those 2 hours in the morning hundreds of thousands of orders. And at some point, the orders grew so much that they were not able to maintain the load. So a lot of orders would either be duplicated or they would be lost. So the day after, the bar or restaurant would get 2 trucks of Heineken in front of their door with twice the order that they made, or they would not get any Heineken at all. And of course, they have to eat to sell the beer from the competition. One thing that advanced mesh and event-driven architecture enables you to do is to buffer the sales and input. So it would basically acknowledge the fact that the request is sent, and it can quickly then store it for maintenance or for management the day after. A similar example is the one of the tax authority of India. You can imagine on the last day of submitting the taxes in India, there's hundreds of millions of people submitting taxes. You don't want to have to manage that order right and there, but you want to be able to acknowledge that the order has been received, and then in due time you actually manage. So you can buffer that order and make sure that no order is lost, which is the most important thing. And
As
this,
a
of course,
scalable environment, is it possible with event-driven architecture? Also, we know that in the offline scenarios, is it possible, but it was not scalable then.
Correct. Yes. Yeah, exactly. A lot of organizations, whether in manufacturing, retail, in CPG, are struggling with this type of situation. They think their architecture is real time, but when it comes with bursts of order, they're just not able to manage them. Just retailers, for example, lose only on Black Friday, they lose around 1 to 2% of their orders annually. So 1 to 2% of their annual revenue is lost on Black Friday, simply because sometimes they just get too many orders that they cannot produce. If you're a Kroger, you'll be able to save 75 million every year just on Black Friday alone, just out of making sure that no orders is lost.
It's huge.
Again, one more example from the retailer. This involves AI. Approximately 40% of the checkout line are self-checkout lines in retailer these days, in average. And what happens very often is customers are scanning the items, but either willingly or unwillingly do not scan some of the items. So apparently 4% of the items that are scanned are not paid for in average, right? So they're not actually scanned. So a number of retailers are experimenting with us to place cameras to monitor how the scanning is done in order to send someone to help the shopper in case they have not scanned the items properly. And this could reduce hundreds of millions of losses every year. So this was just a few examples. I can certainly share more. Let me maybe switch gear here and discuss how is it relevant in an SAP ecosystem and how does it fit in the offering of SAP. Well, first of all, if you're an S4 client, what you have just bought is a beautiful Lamborghini. This is a super fast system which has been designed to be instantaneous, right? S4 by design is a system that is real time, because anything that happens, it gets stored in memory, and anybody connected directly into S4 will receive that instantaneously. The problem is most architecture are designed in a way that while within S4 you are instantaneous, the moment you use another application in the ecosystem, you will probably get that update in seconds or minutes or hours. And so it's like having a beautiful Lamborghini, which is super fast, but that Lamborghini is actually sitting in the desert because you cannot use the speed of that car because you don't have the roads, right? You don't have the connectivity to make the whole architecture real time. It's just your own one system, which is real time. So is Advanced Mesh, is EDA replacing the traditional way of doing integration? Over time, it will replace a number of them. There will still be some scenarios which are better kept point to point, right? So you still have cloud integration as the standard scenario when you're streaming large amounts of data here on the right? And that, but if you have a lot of data, right? This goes without saying, right? You also might need to have some master data integration. Some ETL is sometimes needed. So this is not there to go away, but in many cases you can replace it. Think of some of the batch works you have right now. You can definitely replace that. APIs are there to stay, right? So you still want APIs to happen. But what Advanced Mesh can do, what EDA can do, is it can make these APIs asynchronous instead of synchronous. In other words, I don't need to keep asking data to the API. The API will be triggered only when that event happens, right? And so there's a nice overlap of using EDA with API, because the APIs becomes asynchronous and the whole architecture becomes a lot faster. So I'm just going to pause there for now. I mean, there's a couple of more info we can share, but certainly we'll share this with you. There's a number of resources, learning opportunities to get you started. One of the things that SAP does with us is we often do some workshops, and we can certainly do them with the friends from NDP to get you started on understanding the use cases, or also hands-on to get you to use the technology and try it in a rapid prototyping mode. I'm just going to pause there on the presentation side. Don't worry, you'll receive this stuff later. To see if there's any questions, certainly from Fatih and Fatih, the Fatih brothers, right?
Yes. Yeah, so far, Giuseppe, thank you for a valuable contribution. And also thank you for attending today's webinar for the event-driven architecture. This is our first webinar. I hope it will be proceed with the other webinars then. But for the start, I think it was very a pretty brilliant presentation. Thank you, Giuseppe. We are working on an integration project together closely with Fatih in some of cloud integrations. We are using currently only the middleware like cloud integration, but we need more speed, more real-time integrations, and we will use definitely in our customers an event mesh, I think. And for that case, we need your help with Solus, I hope. And thank you for attending. If you have any further questions, guys, yeah, you can send me an email through info@mdp Group. Yeah, thank you and goodbye.
Thank you, everyone.
Yo.
Bye.
Thank you. Bye.